TV T is equal to new TV. ठीक है? So T is a reference and it refers to TV. तो TV का ऑब्जेक्ट ये है. This is TV का ऑब्जेक्ट and reference T will refer to TV. Okay. Now, when you pass this T to perform on method, it gets collected in ref. So ref क्या है? Ref is a reference. Yesterday I told you that whenever you draw diagram, especially on the top of reference you write type. तो T का type है TV. Ref, we pass T to ref. Ref is another reference. And what type of reference it is? It is electronic appliance. ELAP. I'm just writing in short. So this ref will refer to the same object where T refers to. So ref will refer to same object. And using this ref, when we say on, which on will be called? TV ka on will be called. Yes or no? Yes. Who asked this question?
Okay, yes sir. Yes, sir.
Okay. थोड़ा रिवाइज करो, रिवीजन मिस मत करो. Revision has to be done. Okay. Demo 34. In this we have two interfaces. Before we see demo 34, I would like to show you one note related to interface prior to Java 8. I guess that is in demo 4. Today I am going to give you demo 5. Sorry, not demo 5, day 5. Today I am going to give you day 5. In day 5, there is a note, interface prior to JDK 8. Interface prior to JDK 8. Let us go through that first and then we'll continue with demo 34. Yes. Now we have already discussed about interface, what is the main use of interface, when to go for interface. Now these are the points for interface prior to JDK 8. I'm not discussing about JDK 8 interface. Interfaces are abstract in nature. Interfaces are abstract in nature. That means they cannot be instantiated. Like abstract class, they cannot be instantiated. Interface can contain method declaration. Method which is declared inside interface is by default public and abstract. Variable which is declared, we can declare any member also inside interface, but that member will be by default public, static and final. By default public, static and final. A class can be derived from one or more interfaces. This is something special. Class can be derived from one or more interfaces. As you know, class cannot be derived from one or more classes. That is not allowed. Class can be derived from one or more interfaces. Here we use implements keyword. Child class has to define all the methods of parent interface or interfaces. Otherwise, you need to make child class also as an abstract class. One interface can be derived from one or more interfaces. So between interfaces also you can have inheritance. One interface can be derived from one or more interfaces. That time we should use extends keyword. So class implements interface. Class extends class, interface extends interface, and last point is if a class is derived from some other class and some other interfaces. Combination. Child class is derived from parent class as well as some interfaces. In that case, the rule is first extends keyword should come and then implements keyword should. So extends keyword should precede implements keyword. Have a look at all these points and then we'll continue with demo 30. Read all these points.
Hello, sir. Sir,
Yeah.
is there constructor in interface?
No, not at all.
Excuse me, sir. Sir, can you explain the third point? Variable which is declared one.
Now, interface usually will have contract, abstract methods. Very rarely we can have some member inside interface. Suppose int num, if I define. So by default, that int num is public, static, and final. If we declare that.
So, sir, at the
That's a
time,
very
it is
rare
at
application.
3 stages at the same time. They can be public also, static also, and final also.
Public, static, final, both, all combination of all.
Okay.
So when I just declare any member, it is public, it is static, it is final.
Then, sir, it will be accessible without any
Yeah.
getters methods.
Yeah. So application is very rare about that. Okay. Interface with abstract method, yes, that's quite common.
So does it support static block?
No. No block. Okay. Now we'll see demo 34. Okay. Interface EMP1, void display1, public and abstract. Interface EMP2, void display2, public and abstract. So there are two interfaces here. Class sub1 implements EMP1, EMP2. So sub1 is derived from EMP1 and EMP2. That means sub1 has to define both display1 and display2. And that public is compulsory. It has to be public. Public void display1, public void display. So implements EMP1, EMP2. Okay. Demo 35. How this example is different from 34. Interface EMP1, interface EMP2, interface EMP3 extends EMP1, EMP2. We just read that one interface can be derived from one or more interfaces. And in that case, we have to use extends keyword. So interface EMP3 extends EMP1, EMP2. And then our subclass implements EMP3. Now EMP3 has got display3 as a contract. But EMP3 is also derived from EMP1 and EMP2. And they have got display1, display2. So when our child class, sub1 class implements EMP3, that sub1 has to define three methods. Method from EMP1, method from EMP2, and method from EMP3.
Sir, in it means it is a example like inheritance means we can say that it is an example of inheritance.
This is inheritance only going on.
Okay.
So please scroll to main program.
Main is just create object of sub1 and invoke display1 display.
Sir, in this program, s1.disp, it's called just sub1 only, or it can go to the that interface.
Now, why will it go to interface?
It's like
We are creating object, so s1.display1. Yesterday we discussed, no? Now we know that concept, s1.display1. Every by default we have late binding in Java.
yes.
So for compiler, S1 is of sub1. So
Yeah.
compiler will check whether display1 is there in sub1. Yes, it is there. Whether accessible? Yes, accessible. Now compiler writes instruction for runtime to follow. During runtime, check the content of S1 and invoke display1. So during runtime, content of S1 is sub1 का object. तो sub1 का display1 case पर.
Sir, it means multiple inheritance for interface.
Don't say multiple inheritance in case of interface. Say that one interface is derived from multiple interfaces.
Okay.
Even though some people call it as multiple inheritance, but I told you multiple inheritance in the real sense is with the classes. When one class derives behavior from multiple concrete behavior from multiple classes, that is the real multiple inheritance.
Okay, sir.
Okay. 36. Yes. Interface EMP1 with display1 contract, EMP2 with display2 contract, EMP3 extends EMP1, EMP2. Already we have seen this display3. And now how this example is different, we have one separate class called as base, which has got print. And finally, sub1 extends base implements EMP3. Sub1 extends base implements EMP3. When a class derives from another class and interface, extends and implements both keywords, they come. In that case, the rule is extends keyword must precede implements keyword. So extends base and implements EMP3. Now think about this class sub1. What this class sub1 must do? Must. Compulsory. What is compulsory here?
Abstract methods of the implement.
Class sub1 must define all the methods from all interfaces. As far as base is concerned, base method can be inherited in sub1, or at the most, sub1 can override that method. Yes or no?
Yes.
Huh?
Yes, sir.
Yeah. So sub1 has defined display1, display2, display3. What about print? Sub1 will simply inherit that. So that means when you go in main function, when you create object of sub1, you can call all these methods.
So can we show the output for that?
Output.
Yes, thank you, sir.
Demo 37. That shape example which we saw yesterday. Shape example which we saw yesterday with the abstract class shape and void draw abstract method was there. So again, we can think of that contract. Since we have only contract, instead of abstract class, we can go for interface. So instead of abstract class shape, we can have interface shape. Void draw, class triangle implement shape, class circle implement shape, class rect implement shape, class poly implement shape. So there are 4 classes which are derived from that shape. And now that code which you saw yesterday, static void perform, shape ref, when you pass rect draw will be called, when you pass triangle draw will be called, when you pass poly draw will be called, polymorphic invocation, ref dot draw, polymorphic invocation. And all these methods must be public in all these child classes. Okay, now I would like to tell you one more thing about abstract class, which is very, very important, and that is, we have discussed final class base. What is final class?
It cannot extend.
Cannot be inherited.
Final class is a class which cannot be inherited. That means you cannot have a child of final class. And yesterday we saw abstract class. Abstract class, say, base 1, which normally has got contract, abstract method, abstract void display, let's say. Now question arises, we have seen final class separately, we have seen abstract class separately. Can a class be final and abstract both? Think?
No.
Why no?
Because there is no use for that class. We can't create object. We can't inherit this
Create
class.
We
There
cannot
can
use
be
We have
inherited.
to define its method.
abstract class
Child
can
class.
be inherited.
Final and
If a
abstract,
class is abstract, there is need to create child in order to complete it. But if a class is final, we cannot create child. Both are opposite.
yeah, both are opposite, both are contradictory. Final stops inheritance and abstract encourages inheritance. So that's why you cannot have a class both final and abstract. Okay. Demo 37. No, 38. Sorry. 38. What we'll get to see in this 38? Let's see. Class base, public void display, class sub1 extends base, sub2 extends base, sub3 extends base. So what type of inheritance this is?
Hierarchical.
Multi-level.
Hierarchical.
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 People have got doubt about that. It's hierarchical.
Yes, sir.
One parent and multiple
Parent,
child
multiple
classes.
child.
Yes, same
Hierarchical.
thing.
Hierarchical. Okay. So base class has got void display, and all child classes they are overriding. एक मिनट